Hello students, welcome to Educate. In this class, we will discuss about the quantum mechanical model of atoms. Various models of the atoms we have discussed earlier, like Thomson's atomic model, Rutherford's atomic model, and the Bohr's atomic model. Now we will discuss about the quantum mechanical model of atoms. First of all, what is quantum mechanics? What is quantum mechanics? So previously you have studied about this one in the last class. We have discussed about the de Broglie's wave equation and the Heisenberg's uncertainty principle. In de Broglie's wave equation, we comes on the conclusion that when any particle will be in motion, then that particle will have the wave characteristic also. And the expression was lambda equal to h upon p or lambda equal to h upon mv, where h was Planck's constant, their value was 6.6 into 10 to the power minus 34 joule second, and p was momentum, mv that's also the momentum, and in that case mv the mass of the particle which is in motion, and v was the velocity with which that particle was in motion. So now here, same here, that the quantum mechanics that considered about the wave characteristic as well as the particle characteristic both. So quantum mechanics here given already, the branch of science that takes into account this dual behavior of matter is called quantum mechanics. Dual behavior of matter means that matter will have wave characteristic as well as particle characteristic also. So that is quantum mechanics, that is the branch of science that takes into account the dual behavior of matter, that is quantum mechanics. Now quantum mechanics is a theoretical science, that is theoretical science. Previously there was Newton's classical concept that was applicable for the macroscopic substances, but this quantum mechanics that is applicable for the macroscopic object as well as the microscopic object. Classical physics based on the Newton's law of motion that was applicable for macroscopic object, but the quantum mechanics will be applicable for the macroscopic object as well as the microscopic object. Now here, that was quantum mechanics. What was that? Now the quantum mechanics was developed by Schrödinger and the Heisenberg's. You already know the Heisenberg's uncertainty principle. What was that? The Heisenberg's uncertainty principle stated that when any object in the motion, when any object or when electron was in the motion, then we cannot calculate both position and the momentum of electron simultaneously after a certain accuracy. So that Heisenberg's as well as the Schrödinger's both developed the quantum mechanical model of atom. So write that here also, the Schrödinger's and Heisenberg's. That's right. In your notebook you should write there. So the Heisenberg's and the Schrödinger developed the quantum mechanical model of atom. And what is quantum mechanical model of atom? That means that model of the atom was prescribed in which the wave characteristic as well as the particle characteristic, both wave characteristic as well as the particle characteristic, that is dual characteristic of electron was considered. That is here quantum mechanical model of atom. Here one significance of the quantum mechanics is that when the quantum mechanics applies over the macroscopic object, the macroscopic objects in which the wave characteristic was meager or insignificant, in that case also the quantum mechanics holds true. So that's the significance of quantum mechanics, that the quantum mechanics is applicable for both microscopic object as well as the macroscopic object. While the classical physics or classical mechanics, the classical mechanics was applicable for the macroscopic object only. So classical mechanics do not applicable for the microscopic object, while the quantum mechanics that is applicable for not only the microscopic object but for the macroscopic object also. And the quantum mechanical model of atom was developed by Heisenberg and the Schrödinger. Okay, so this one point here, and that's who have proposed, that could be asked in the NEET examination as well as in CUET examination. But in case of IIT main, the question about the who have developed the quantum mechanics or quantum mechanical model of atom is very less, but its importance could not be denied for the IIT main examination also. Okay, so that was developed. Now Schrödinger equation, what is that? Schrödinger have provided an equation that is H psi equal to E psi. H psi, this is kappa, this is caret here. H, this one here, like H psi equal to E psi. Here the value of H is a mathematical operator called Hamiltonian. This one, H is mathematical operator that is called Hamiltonian, and this E is the total energy of atom, like potential energy, kinetic energy, and so on. So E is the total energy of the atom, that is E. So H psi equal to E psi. Here guys, don't consider that the simple mathematics don't apply, that this psi can be cancelled. No, that is different terms. So someone may think that why not this psi and this psi cancel out, so H kappa, that will equal to E here. Sorry, H caret equal to E. Actually not, that has not a simple meaning here, that has complicated meaning, and that is here not relevance for you. This one you will not have to study in so much detail about this equation. You will have to study in the higher class. But guys, from here the question asked in the IIT Advanced. So about that I shall make a separate video in which I shall discuss about the Schrödinger wave equation in detail. You will have to study in this class only little bit about the quantum mechanical model of atom here, and that means the Schrödinger's equation, particularly about the Schrödinger's equation. Here you will have to study very less. It has wide relevance, but it is not included in your syllabus. That is included in the very small portion of the Schrödinger equation is in your syllabus. So about that, but it is important for IIT Advanced, so I shall make a separate video which will be exclusively for the IIT Advanced. Okay, in the IIT main examination there is also probability of asking the question related to this topic, but that will be less. In here in NEET examination also there is probability of asking the question from the Schrödinger equation, But here, for the who is preparing for the 11th class only, so he will not have to study about the Schrodinger equation in detail. So that is here Schrodinger equation is this one. Now here hydrogen atom and the Schrodinger equation. So about the Schrodinger equation here, he have solved about the possible energy levels of electron occupying the corresponding wave functions. Okay, so according to this one, Schrodinger's wave equation here, that is there is 3 quantum number by which we get complete information about the electron. Here psi is actually the for the wave function, and psi square have keep in the mind only. But of who is preparing for the NEET examination or the main examination, psi square that has the relevancy, but psi has not a relevancy. Psi square, that is amplitude of the wave. Let's see that is how does it when a school question. Okay, this one has been given that this one hydrogen atom and the Schrodinger equation that has stated that the wave functions of the electron, wave functions that is characterized by 3 quantum numbers. This one 3 quantum number, that is principal quantum number, azimuthal quantum number and the magnetic quantum number. These 3 quantum numbers, that is principal quantum number, azimuthal quantum number and the magnetic quantum number, that gives the complete information about the wave characteristic of the electron, about all the information about the waves functions of the electron that we get informed by the principal quantum number, azimuthal quantum number and the magnetic quantum number. Okay, that has been given here. Here, this one here, in this case, or here he have provided about the hydrogen atom, and he have told that the wave functions of hydrogen atom or hydrogen-like species like He plus, Li2 plus. These hydrogen-like species with 1 electron are called atomic orbitals. This one wave functions of the hydrogen or hydrogen-like species with 1 electron, that is called atomic orbitals. Okay, so orbitals is what here? Orbitals is the region of space. Orbitals is the region of space where the probability of finding the electron is maximum. As Heisenberg's uncertainty principle have informed you that the position and momentum both cannot be calculated accurately. So here we will tell the quantum mechanical model states that about the probability of finding the electron. Okay, that means it's not necessary that electron will occupy the position only at this place, but the probability of finding that electron will be maximum at that place. That is it. This one is here. Now some here, let's see about this one. Important features of the quantum mechanical model of atom. Important feature of the quantum mechanical model of atom. So first one is energy of electron will be quantized. As we have discussed there also, Niels Bohr have also given about the information that the energy of any electron will be quantized. Keep in the mind, nh upon 2 pi, that was given by nh upon 2 pi, that was provided by Niels Bohr about that. So here also it has told that energy of electron in an atom is quantized. That will be not in discrete manner, that will be quantized. Here the second point is the existence of quantized electronic energy level is a direct result of the wave like properties of electrons and allowed solutions of Schrodinger wave equation. That is here tells that the existence of quantized electronic energy level, that is direct result of the wave-like properties of electrons. Okay, so as Schrödinger's wave equation has provided about that, so that is here quantized electron energy level is the result of wave-like properties of electrons. Okay, and same obviously the exact position and exact velocity of the electron cannot be calculated here. That is as provided by the Heisenberg's uncertainty principle. So quantum mechanics considers about that both the position and the momentum of electron cannot be calculated exactly, accurately. The both position and momentum of electron cannot be calculated accurately. About that, the quantum mechanics has been considered. Next one is here atomic orbital. What is atomic orbital? That is the wave function of electron in an atom. Whenever tells about the atomic orbital, so that is here. That means the atomic orbitals means that is the wave function of electron in the atom. That is. Okay, one point here is also an orbital cannot contain more than an orbital cannot contain more than 2 electrons. That is here about that you will also study. There will be maximum 2 electron in any orbital. Okay, and orbital is the wave function of an electron here. Okay, orbital I have also taught you that orbital is the region of space where the probability of finding the electron will be maximum, and that is here the wave characteristic of electron, that is wave function of an electron, that is orbital, atomic orbital. Okay. So next point is all the information about the electron in an atom is stored in its orbital wave functions, and quantum mechanics makes it possible to get this information. Okay, so all the information of the electron can be find out by the orbital wave functions. Okay, now so it is next point is here the probability of finding an electron at a point within an atom is proportional to the square of the orbital wave function, this one. So probability of finding an electron will be how wise, that will have psi square. I have also told you that has the significance psi square and not of the psi. So that is here also given here that the probability of finding an electron at a point within an atom is proportional to the square of the orbital wave function at that point. And here this one here psi square is known as, this psi square is known as probability density, and that will be always positive, can never be negative. The probability of finding the electron can never be negative, that will be always positive, and this psi square is called probability density. Okay. So that's here same. So from this value psi square at different points within an atom, it is possible to predict the region around the nucleus where electron will most probably be found. Okay. So that is here. That is here psi square. By the help of psi square, the orbital can be defined. Okay. Now orbitals. What is the orbitals? That's we have discussed about that. So can anyone tell about the difference in orbit and the orbital? Anyone? So orbit is the path along which the electron moves. So that was provided by Niels Bohr. Niels Bohr have provided that the path along which the electron revolves. So that was, he called that orbit. And orbital is the region of space where the probability of finding an electron is maximum. Orbit, in case of orbit, that was considered only about the particle characteristic of matter, while the orbital that considered the dual behavior of matter. That is, the concept of orbit was applied by Niels Bohr, and in that concept only the particle characteristic of matter was considered, while the orbital concept, the concept of orbital, is provided in the quantum mechanical model of atom, and here not only the particle characteristic but the wave characteristic of electron has also been considered. That is here orbital. Now, what was that is atom orbitals and orbital. That is the main difference. And obviously, the orbit is a two-dimensional phenomena. Two-dimensional, but the orbital is a three-dimensional quantity. The orbit is a two-dimensional quantity, while the orbital is a three-dimensional quantity. Okay. Now, then after here about the complete information, that is the 3 quantum number. The 3 quantum number gives the complete information about an electron, and that are the principal quantum number, azimuthal quantum number, and the magnetic quantum number. First one is the principal quantum number. So the quantum number, that is here, this quantum number is the set of 3 numbers. Some books write 4 numbers, but actually there is a fourth quantity is the spin quantum number. The spin quantum number informs about the electron is rotating in clockwise or in anti-clockwise, but particularly these 3 atomic orbitals, that is principal quantum number, azimuthal quantum number, and the magnetic quantum number, that gives the complete information about an electron. So first one is the principal quantum number. Principal quantum number. The principal quantum number informs that the electron is revolving in which cell? This one. Electron is present in which cell? That is that information given by the principal quantum number. And this principal quantum number that determines the size and large extent the energy of the orbital. So principal quantum number gives information about the size of atomic orbital and the energy of atomic orbital. So principal quantum number informs about the size of atomic orbital as well as the size of atomic orbital as well as the energy of atomic orbitals, and this also identifies as cell. That means the principal quantum numbers identifies that electron revolves around the nucleus in which cell. So how much in any cell the number of atomic orbital will be n square. Listen here. Okay, your Niels Bohr's atomic theory that also stated that the number of electron in any orbital, in any orbit, will be according to 2n square. Since in one orbital there be 2 electron, and the number of orbital in any cell will be according to n square. So maximum number of electron in any cell will be 2n square. Okay. Okay, that is here. So number of orbital in any cell will be according to n square, where n is cell number. So in first cell, the maximum number of electron will be n equal to 1. So okay, here in first cell, number of orbital, that will equal to 1 square, that is 1. In the same way, in second cell, Same in third cell, what will be there? So that is here, this one. So number of orbital in any cell will be according to n square. That's keep in your mind. That number of orbital in a cell will be according to n square. And that's the reason the maximum number of electron in any cell will be according to 2n square. That was about the principal quantum number. It informs you the size of the orbital and the energy of orbital. So principal quantum number informs you about number one is size of atomic orbital, size of atomic orbital, and energy of atomic orbital. That is size and energy of the atomic orbital will be informed by the principal quantum number. Now second one is azimuthal quantum number. So n was cell, this azimuthal quantum number will be subcell. So azimuthal quantum number informs that the electron will revolve in which subcell or which sub levels. Okay, this one azimuthal quantum number or orbital angular momentum or subsidiary quantum number. So here the azimuthal quantum numbers will also inform you that what will be the value of angular momentum of electron. When you will do in the physics, then when you will find out the dimension, unit and dimension chapter you have studied in physics. So when you will find out the dimension of the angular momentum, then you will find out that their dimension is same as that of energy, ml2 t minus 2. So energy, work, and angular momentum, all these three will have same dimension. So here it is equivalent to energy. Work can be converted into energy, energy can be converted into work. You will study about that that means in the next chapter, when you will study few more chapters in the physics, then you will realize that both work energy and angular momentum are interconvertible. So that's azimuthal quantum number informs you that what will be the orbital angular momentum, what will be the angular momentum of any orbital, that will be. And so that means the azimuthal quantum number will also inform you the contribution of angular momentum in the total energy of any orbital. The contribution of angular momentum in the total energy of orbital, that information will be given by azimuthal quantum number. Your principal quantum number informed you that the electron will be present in which cell. Like that, the azimuthal quantum number will inform you that the orbital or the electron will be present in which subcell. Okay, that is orbital, that is azimuthal quantum number. Now angular, that is principal quantum number, that was represented by n. Principal quantum number that was indicated by n, and here the n was written as 1, 2, 3, 4, 5 like that. The azimuthal quantum number, that is represented by L, and this L is equal to 0 to n minus 1. So in any cell, what will be the number of subcell? That will be according to 0 to n minus 1. As for example, for first cell, that is 1 2 3 4 or KLMN, like that. The principal quantum number indicated by 1 2 3 4 or KLMN, that means first cell, that will be represented by K, the second cell by L, third cell by M, and fourth cell by M. In the same way for first cell or K cell, N is here 1, so their L will be equal to 0 only. 0 means S subcell. 0 means, it not means 0 is the not the value. 0 represent about the S subcell. So the in first cell there will be only one subcell, that will be 0, and 0 is indicated for S. Like that, 1 was indicated for K cell. In the same way, 0 will assigned for the S subcell. In the same way, for second cell, or L cell. So L will be equal to how much? 0 and 1, because 2 minus 1, 1. So that will be 0 and 1 only. So in second cell, there will be two subcell, that will be S and the T. So in second cell, there will be two subcell, that is S and T. In the same way, once more I am taking for L subcell, what will be there? And for M cell, what will be there? For third cell, for M or third cell, L will be equal to 0, 1 and 2. 0 for S, 1 for T, and 2 for D. So in third cell, there will be three subcell, that is S, P and D. But in third cell, there will be three subcell, that is S, P and D. That was about the azimuthal quantum number, that represented by the azimuthal quantum number, that represented by L, and this azimuthal quantum number informs about the angular momentum associated with an electron. In addition to that, the azimuthal quantum number informs that the electron is present in which subcell, or the orbital is present in which subcell, that is get informed by the azimuthal quantum number. Okay. Now then after is magnetic orbital quantum number. So that is a magnetic quantum number that informs about the spatial orientation of the orbital. That means orbital is in which axis? X axis, Y axis, Z axis, along which one? So about the orientation of the orbital, that get informed by the magnetic orbital quantum number. That is magnetic orbital quantum number that informs that the spatial orientation of the orbital with respect to a standard set of coordination axis. So which coordination axis you have selected? With respect to that, what's the spatial orientation of the orbital, that get informed by the magnetic orbital quantum number. And this value of M, it is magnetic quantum number, that is represented by M, small m. Like principal quantum number was informed by N, the azimuthal quantum number was indicated by L, and in the same way the magnetic orbital quantum number, or simply the magnetic quantum number, that will be indicated by M, and this M will be equal to 2L plus 1. That is 2L plus 1 in any orbital, in any cell. What will be the orbital, what will be the number of orbital in three-dimensional space? That will be given by 2l plus 1. As for example, for l equal to 0 or s sub cell, for s sub cell l equal to 0, so m equal to also 0. That means in s sub cell there will be only one orbital, that is 0. Same for p sub cell. For p sub cell l is equal to 1, so m will be equal to minus 1, 0 and plus 1. So that is the value, and its value of l is, that is m is l, that is the value of l is from l to 0 minus l, sorry, that is from minus l to 0 and that to plus l. So that's why number of orbital will be 2l plus 1. So for p sub cell l will equal to 1, so m will be equal to minus 1, 0 and plus 1. So minus 1 here, so that will be called, this is called px, py and pz. So that means in p sub cell there will be 3 orbitals, that will be minus 1, 0 and plus 1. Now for d sub cell, d sub cell l equal to 2, so m will be equal to minus 2, minus 1, 0, plus 1 and plus 2. So total number of orbital in the d sub cell will be 5. So in d sub cell, that means the number of orbital in d sub cell will be 5. That is minus 2, minus 1, 0, plus 1 and plus 2. Next one here is spin quantum number. A spin quantum number that indicated by S. So a spin quantum numbers only here, that is informs that the electron will revolves in clockwise or in anti-clockwise, as the name indicate spin. So spin quantum number means that will tell us about the spinning of the electron. Spinning of electron means the revolution of electron, that will be either clockwise or the anti-clockwise. That is here. So what is here? The 3 quantum numbers, that is like principal quantum number, that tells about the energy, the azimuthal quantum number that tells about the shape, and the magnetic quantum number that tells about the orientation of the electron, chief characteristic. That is mainly the main information given by these 3 quantum numbers are the principal quantum number inform about the energy, the azimuthal quantum number inform about the shape, and the magnetic quantum number inform about the orientation of the orbital. So that is here. This one here not sufficient to explain about the line spectra observed in multi-electron atoms. That is, so about the 4th quantum number, who have informed Uhlenbeck, Goudsmit, Uhlenbeck and the Goudsmit, that informed about the 4th quantum number, that is spin quantum number. So there is 2 spin states of the electron, that is clockwise and anti-clockwise, that is this sign, spin up, spin down. Okay, in the summary here is given to some of the fourth quantum numbers, provide the following information. So that is, n defines the cell in which the electron or the orbitals are present. That also informs the size of the orbital and energy of orbital. The principal quantum numbers informs about the size and energy of orbitals. About that we have already discussed. Then after is azimuthal quantum number. What does that give? That shape of the orbital. It determines that the shape of the orbital. M, that will give about the orientation of the orbital. Okay, written in different way, that you will find out. On spin quantum numbers inform about the spinning of the orbital. So that is here, ms refers to origin of the spin of the electron. Now question number 2.17, let's see. Question number 2.17. What is the total number of orbitals associated with principal quantum number n? So you already know that the total number of orbital in a cell will be according to n square. You have studied. I have informed you already in this class only. That is the total number of orbital in a cell, that is equal to n square, and n here is equal to 3. Here the value of n is 3. So that's why in third cell, okay, that was first question was that, and that was the first question was how much easy you can find out. That simply put the formula, get the result type, and actually the concept was that in any cell the number of orbitals will be according to n square. Now let's see the second concept, second one about this question. About SPDF notations, describe the orbital following of the following quantum number. N equal to here, n is 2. Okay, L is 1. So L is 1 for P. You have already written 0 for S, 1 for P, 2 for D, 3 for F, and so on. That is, so let's see here, n equal to 2. So that will be 2. Then after this L is 1. 1 is for P, so P here. So 1 P. Second one is what? So A is what? Second. N is 4. So write that here 4. And L is 0. So 0 for S. Watch out here. So that means 4S. In C here, N is 5. So 5 here. N is 5. So simply 5 here, and L is 3. 3 is for F. So 5F. Now let's see in D. In D, N is 3. So 3. L is 2. L is 2 for D. So that means 3D. So that is here. Okay guys, actually quantum mechanics is not difficult. Since there is some imagination, that's why students feel difficulty about the quantum numbers, about the quantum mechanical model of atom. The students get scared only because they will have to think. Actually, this topic is also easy as the previous topics were. So there is no difficulty. So about the shapes of atomic orbitals, about that we will discuss in the next class. It's all for this class. Thank you, Team Educate.